Oh, good, it's recording to the
It's
cloud.
recording now,
Okay,
so.
gracias, señor.
Está listo, David.
Okay, adios.
Yeah.
Okay, so now let me introduce myself. My name is David Arietti, and as I mentioned earlier, I've been at Oakland 37 years, and my main field is environmental science, okay? But I do teach both classes, environmental science and biology. However, lately, the majority of my time was here teaching biology at the Skokie campus, although occasionally I'm at this campus, the Des Plaines campus. So anyway, as you all know, this is a special month. It's Sustainability Month, and we have various events going on. And one of the events scheduled is my lecture on microplastics. Now, microplastics is an issue that has to do with environmental health. And unfortunately, everybody on the planet is being affected by this because all over the world, thanks to the oceans and the winds, we see plastic, okay? And plastic makes its debut every day in the plastic bottles all over the world. I think there's billions and billions of these plastic bottles. Many of them contain water, and even the water contains small amounts of plastic. So we'll be talking about microplastics in general. So let me begin here. And in fact, I will use this, okay? Now, human activity has led to microplastic contamination throughout the marine environment, which means the oceans essentially, okay? And as a result of widespread contamination, microplastics are ingested, which is another word for eaten, by many species, including humans and fish and shellfish, you know, such as oysters, clams, things like this, and virtually everything else that eats. All right, now, since 1950, humans have created more than, you ready for this? 8 billion tons of plastic. Now, the problem with this statistic, since we talk metric in my class, I am not sure what kind of tons they're talking about. If it's a metric ton, a metric ton is equal to 2,220 pounds, whereas the short ton is equal to 2,000 pounds. So we'll be off by 10% if they're talking metric, but I don't want to go into that. But I'm just mentioning that that's something you should be aware of, since in my class, since I deal with science, everything's in metric, okay? So again, there are 2,200 pounds, 2,200 pounds in a metric ton and 2,000 pounds in a short ton. I think I used the word 20, but that was an error. 2,200 pounds in a regular ton. Anyway, only about 9% of the plastic has been recycled, and so people who eat contaminated shellfish and other species are picking up the plastic. Now, to start off, I just want to show you a quick movie about how plastics are made, and this is really easy to understand and short, because we'll see that there was a question asked to this person who presents this, and let's see if we can get it going here. There it is. Okay, it lasts about 5 minutes, and I think what I'll do is speed it up. Let me.
I have a question. How's plastic?
Ooh, that is a really good question. These days, plastic is getting mentioned a lot in the news.
Can you all hear it?
Not in a good way.
Okay.
You might have seen videos of plastic garbage floating in parts of the ocean. And maybe you've heard the fact that plastic doesn't break down very easily. So when plastic gets littered or tossed on the ground, it's often there to stay for a long time. Not only does that look ugly, it can harm wildlife that mistakes it for food or gets tangled up in it. You might wonder, if plastic seems to cause all these problems, what good is plastic? Like, why do we even have plastic at all? Before I say anything more, now we have been kind of pause the video to discuss. Why do you think we have plastic? Okay, you ready? Well, there's not just a bad side to plastic. There's a whole other side of plastic that you might not know about. What I like to call the good side of plastic. And to know what's good about plastic, it's helpful to know why plastic was invented in the first place. You see, a long time ago, more than 100 years ago, plastic wasn't even a material that things could be made of. It hadn't been invented. That means any of the things in your life today which are made out of plastic Think about it. That means everything from combs to eyeglasses to the toys you grew up with. All of these used to be made of different materials. Materials we had to go out and gather from nature. Materials like bone, wood, and antlers, even turtle shell. One material that was especially valuable was this, ivory, which comes from the tusks of elephants. People eventually realized that if they kept making things out of materials like ivory and turtle shell, there'd be no more elephants or turtles left. Scientists and inventors stepped up to try to solve the problem. They experimented to develop a new material, one that would be just as long-lasting and useful as ivory or turtle shell, but one that could be made, created, without having to go hunt animals. And they discovered it. Plastic. One of the great things about plastic is that lots of it can be easily made using leftover parts from oil, stuff we use to make gasoline. By combining those leftover parts with a strong substance known as acid, that's how most plastic is made. No animals have to be hunted to make plastic. In fact, in a very real way, the invention of plastic helped to save many elephants and turtles. But wait a second, how can a material that was once good and helpful, not only to us, but to animals, also be the same material that people are saying poses a harm to animals when it's littered? The answer to this is that plastic, like many things in life, isn't always good or always bad. It totally depends on the situation. And it's up to each of us to really think about the ways we're using it. For example, when plastic trash is littered, the fact that it lasts a really long time actually becomes a bad thing, since now the litter won't break down very easily. It looks ugly and it can harm wildlife. But this same property of plastic being so tough and long lasting is exactly what makes it an incredibly helpful material in other situations. For example, in order for us to have telephone and internet connections between all the different places on Earth, people had to lay down giant metal cables along the bottom of the ocean. But the salt water of the ocean would damage the metal cables. A brilliant engineer named Walter Lincoln Hawkins invented an especially tough, long-lasting type of plastic that could be used to coat and protect the undersea cables. Thanks to this use of plastic, people all around the world can talk to one another on telephones and computers. And that's just one of thousands of different ways that people use the good side of plastic. So in summary, plastic is created by combining leftover parts of oil with a strong substance known as acid. Plastic is a tough and long-lasting material, which can be good or bad depending on the situation. That's all for this week's question. Thanks, Juan, for asking. Now, for the next episode, I reached into my question jar. We've got pretty quick.
Okay, anyway, you get the idea. I figure this is a good way to begin something on plastics because we all take it for granted. And we really don't care about how it's made, at least most of us don't. Now, since this talk is specifically microplastics, the word micro means small. So how big are we talking about? Well, plastic can come in all shapes of sizes, but we're talking about the definition. Now, this is the definition of microplastics, anything less than 5 millimeters, okay? Now, what I have done, I put a picture of a ruler up there in millimeters. Now, to let you know, for those of you who are not familiar with the metric system, there's roughly 2.54 centimeters equal 1 inch, okay? And a centimeter is the equivalent of 10 millimeters, okay? So if we look here on this picture here, here we see between 2 and 3, you have these divisions. Each of these divisions is a millimeter, okay? So you have 10 millimeters per centimeter. So I don't want to talk more about the metric system, but that's essentially what it is. So essentially, you can all see a 5 millimeters or half a centimeter and a way below too, without using a microscope or magnifying glass. So in a way, it's not really micro because in theory, micro is very small, but they use that term to classify virtually all the plastics under 5 millimeters or half a centimeter, or roughly, I don't know, maybe one, let's see, we have 1/5 of an inch, something like that. Something like that. Okay. Now, I have here a chart, and what you see in this chart, again, I want to use a little bit of measurements here. Everything you see here in orange deal with life, such as fish eggs, things that have to do in the body, such as particles that may cross the blood-brain barrier of an animal, and other substances which can go into cells. Everything orange is living matter. Everything outside of that, especially the blue, represent things like sand, sediment, asbestos, air pollutants, which are measured in PM, which means particulate matter, okay, which is not living, but which can affect living organisms. And then over here, we have the types of tools for analysis, okay, how they measure this stuff. And there are a number of ways of measuring it. One is called pyrolysis gas chromatography. And then there's this new type of instrument, which is called a Fourier transformed infrared spectrophotometry. And I'm just showing you that just to show you some new equipment that we have to measure all this. And as you can point out, just by looking at the equipment, you can imagine it's quite expensive. Okay, now, we just saw a movie on how plastic is made, but essentially, just to show you, the majority of plastics we have are generally come from oil, okay? So oil contains many compounds. It's not just like one oil. And we're talking about the petroleum stuff you get from the ground, not stuff like olive oil and, canola oil. That, of course, comes from vegetable matter. But here we're talking about crude oil, okay? And this is what makes plastic almost impossible to break down, okay? Because no organism can really break it down, all right? So anyway, the best way of making plastic is by polymerization and polycondensation. And what that means is they take chemicals and it puts it together, okay? That's why you'll hear plastics such as polyethylene and polystyrene and things like this, polypropylene. And we hear polypropylene as these little containers where you put margarine and yogurt and things like this. And of course, the Greek word poly means many. So what they do is they take a monomer, which is one chemical, and they add them together and they make plastic out of it. To give you an example of polymer we all need in our bodies is you have starch and glycogen. And these polymers, which are natural, they're made out of glucose, okay? That's the sugar you have in your bodies. And unfortunately, that's the one that they test for diabetes, okay? So when we have starch and cellulose and things like this, those are polymers of glucose, essentially, okay? So poly means many. Now here we see a finger, and all these are microplastics he dug out of the water somewhere. So as you can see, we have it all over the place. Well, this just gives you an example, okay? Everything there, microplastics. Here we see plastics being fished out of some body of water, and that's a sieve. All that is, it's like a, looks like a ring, and on it, it has like a mesh, such as a screen, and you just put it in the water, and all the particles, which are larger than the hole in the screen, will remain in that container. Now, for those of you who are familiar with recycling, we have 7 ways of recycling plastic. And I want to point out that only about 2 or 3 of these are actually useful. Number 1, these are the PET or PET polyethylene terephthalate, which is good. I don't see any here. And these are the regular bottles. You see the white bottles with the water and other stuff in it, the iced tea or whatever. Those are no good. And I should point out that the only good thing about that is that at home, I have a shirt, a white shirt made with the polyethylene terephthalate. In other words, strands of plastic mixed in with polyester. So the only good thing about that, you can make clothes out of it and it'll probably last forever. Okay. Then, of course, we have the high density polyethylene, and I'm going to show you something real interesting, what we make with these. So we don't have to throw it away. We recycle it into a very useful product that you will see. I'll keep you in suspense until I get to it. Then we have polyvinyl chloride. And as you can see, we actually make pipes out of that, water pipes and other pipes. And then we have plastic bags, which is the low density polyethylene. And this is the stuff where you see essentially breads used to be wrapped in it, like Wonder Bread and things like this. Okay, it's a very thin type of paper. or it's actually a plastic, and they wrap breads in it, okay? And then, of course, polypropylene. These are where you have your yogurt, straws, potato chip packets, things like this. And then we have these disposable cups, polystyrene, and these are really not good for anything. And if you want to have a reaction with that, you put acetone in or you put polystyrene in a liquid acetone, similar to the nail polish remover, and that will dissolve the polystyrene. It'll come like a white liquid or a little clump. And I don't know of any other use for polystyrene. And then you have your 7, which includes these little bottles that parents give their kids when they go to school, the little boxes of orange juice, tomato, apple juice, things like this. Those are the multi-layered plastic, and there's not much you can do with that because it's a real pain in the neck to separate out the different plastics. Probably numbers 1 and 2 are the ones we can really make stuff out of the most. It's possible with the others, but these are the common ones, and I'll show you one in particular. Now, as we all know, garbage is made up of many types of components, and plastic makes up around 12.8% of the garbage, and paper is actually the highest concentration of what's in the garbage patch. And by the way, do you know why the garbage business is a good line to get into? This is a good line to get into because business is always picking up. Just thought I'd mention that. A little extra there. Okay, anyway, and now there are other ways of sizing plastics, but as you see here, we have small microplastics, large microplastics, which they should really put the number 5, but then somewhere between 4.75 and 5 millimeters, not much difference. And then the mesoplastics are bigger than that. And then we go to macroplastics, which are over 200 millimeters, okay? And remember, 1,000 millimeters make up a meter. So that's roughly 1/5 of a meter. You see it anything greater than that, okay? But like I say, we're not going into that. Now, where does the pollution come from? Microplastics. Well, it comes from textiles, clothes, that we wear, tires, and city dust, okay? And this accounts for roughly 80% of all the microplastics in the environment. And unfortunately, even remote places like the Arctic and other places that are associated with the oceans are picking this up. And they've even found plastic at the bottom of the Marianas Trench, which is the deepest area in the world. In the ocean, it's off the coast of the Philippines, and I think it goes down close to 7 miles down, which means it's pretty deep, okay? And there's a lot of pressure there. And of course, submarines can't go there unless you have a specially built one, as James Cameron did, the guy who made the movie Titanic. They built a special submarine, and he went down to the Marianas Trench, and he stayed there for a few minutes. I don't think anybody in their right mind would want to spend a long time down there, and you got to pray that you hope you're able to get back up, where you have to release the lead weights that he had on that specially built submarine because of the pressure. Okay, now I'm going to change this. Now, believe it or not, everybody here washes clothes, and most of the clothes that you wash contains plastic and polyester and things like this. Well, according to the scientists, every wash, when you have about 6 kilograms, and by the way, like I said, a kilogram means 1,000 grams, and 1,000 grams is the equivalent of about 2.2 pounds, okay, just to make it in the English system. So we keep hearing of grams. It's about 2.2 pounds. There's actually 453.57 grams in a pound. So you can imagine how much we have, and they just rounded off to 454 grams in a pound. And again, 1 kilogram is about 2.2 pounds. So that gives you some idea. And again, since I'm in science, we use the metric system. Now, here is something interesting. When you wash acrylic or polyester or cotton, they figure you get whatever you see there, number of fibers per wash. Isn't that something? That's almost 1 million fibers, 728,789. And these are numbers I didn't make up. I never sat there counting myself, but you get the idea. So you see, there's certainly a lot of fibers given off by even clothes. Something as harmless as you think, washing it in the clothes washer, okay? Now, here we have different bottles with different types of water, different companies made in various countries. And you can see over here the flags of the country. Now, Nestle, I believe they were a Swiss company or something, I'm not sure, but they're actually the worst with up to 10,000, over 10,000 microplastics in the bottle, you see, found per liter. Okay, lowest and highest number of plastic particles found in a liter of bottled water. Now, by the way, just to give you some comparison, what a liter is roughly 6% more than a quart. Okay, we use quarts, of course, that's not metric, but the liter is. Okay, and of course, the best one is this Nestle, the one in San Pellegrino water, at 0 to 74. It's funny how Nestle has the most and the least. You see that? That's pretty interesting. And then, of course, we have Aqua. Here we have all these countries where they make the water. So they did a study on these, and the average number in every liter. Remember, a liter is about twice the size of some of the bottles we have here. I think it says 576 milliliters are the bottles that hold about a certain number of ounces. But anyway, this tells you how much is found in each bottle based on the brand. Evian seems to be the best. Even Coca-Cola has some, but it doesn't have that much. You see it compared to the Nestle one. Okay, and of course, Nestle's at the bottom too, but that's a different country. Now, let's talk about the problems of microplastics, okay? I feel you should know about this because these are chemicals. Now, you don't need chemicals in your body, okay? But when you get them, they cause problems. And I want to point out something to you. There's a term for chemicals that don't belong in your body. They're called xenobiotics. Comes from the word xeno, which means stranger, okay? Okay, so you heard of the term xenophobic? That means fear of strangers. Well, xenobiotic means chemicals foreign to your body, which means non-natural substances. You know, maybe 200 years ago, you're going to go out and you'll never pick up plastic because it hasn't been invented, you see? So you're not going to find that. So the xenobiotics, I think, appeared before World War I. And that's when we're making all these millions of chemicals, okay? Now, the trouble with ingesting microplastics is that they cause gastrointestinal problems, and by being in the intestinal tract, they're not going to be absorbed. So you can eat a lot of food, but you're not going to survive because you're going to starve to death. And this is unfortunately what happens with fish and whales. Recently, they found a whale that had 200 pounds of plastic in its stomach. And obviously, the body cannot digest plastic, and the whale died. And this is a big issue that we have. Now, how much do we consume? Okay, here is the issue. You all know what credit cards look like. Well, according to this, which is hard to believe, but I found this doing the research many times, you eat the equivalent of 5 grams of plastic every week. Now, this does seem quite a bit. Could this be an exaggeration? Yeah, it could be. Certain people eat that much. And just to tell you how much that is, you're not exactly cutting up a credit card and gobbling it up, you know, to fill up your stomach. But a credit card, the regular simple ones you're familiar with, weigh about 5 grams. And what I did was weight it on a scale, and it actually came out to about 5.2 grams, something like this, okay? So nobody wants to eat the equivalent of a credit card. Let me take one out here. I got one. And if you want, you can chop it up and put it in your salad. You never know, it might add some flavor to it, you see? Here's a typical credit card that weighs 5 grams. According to the literature, again, you're eating this much worth, okay? Interesting, isn't it? So anyway, you can measure it yourself. It seems kind of a lot, you know? That means you multiply that times 52. And you're getting what? How much is 5 times 52? 250 grams, which is 1/2 a pound, right? In theory. Okay, if if you multiply it by grams, remember 454 grams to a pound, okay? Of course, you're breathing it in and all this stuff, so you gotta be careful. Now, here we see a lot of plastic piled up on a lake somewhere. Now, I'm gonna show you how organisms pick it up. It's relatively simple. Okay, so let me explain what happens. Here's a good picture of it. We have a whole bunch of activity here. We have energy from the sun, and that's going to help to break it up a little bit. It's not going to really decompose, but it's going to break up into little particles called nerdles. Okay, like a nerd, N-E-R-D-L-E-S. Okay, now how do other organisms get it? Well, it's relatively simple. You get the water from sewage is one way, people throw stuff down in the garbage, the sewers, wherever. And then if you have plastic bottles, which I've seen. Now, I want to point out something to you. In 2017, I went to the Amazon. That's right, the one in Brazil, not the book company, because a few of them around here. I could say, hey, I went to Amazon. Yeah, they got a few buildings, but that's not here. I went all the way down to Brazil, and I was there for 11 days. And I went on a 6-day boat trip. We only had 16 cabins, okay, on the boat. What we would do in the boat, we would take 2 field trips a day. Before breakfast, we would get up like 5 in the morning and go with special canoes, looking around for birds and other animals. And for about 2 hours, then we come back to the boat. The only pollution I ever saw on the Amazon were plastic bottles. Nothing else. The water was clean. The only thing, again, I saw were plastic bottles, okay? And I'll try to find one here for that. I might have a picture of it here, if I can find it after the lecture. That's all I found. So the Amazon's relatively clean, except for not too many of these bottles either, okay? So I did find the plastic bottles, much to my chagrin, but at least it's better than finding lots of garbage there, okay? So anyway. So what happens here is, how do we pick up this? Well, if you notice, what's going to happen is you have little particles, fish, and I'm going to show you a good picture of a little animal that fish eat, which is being surrounded by plastic, and you'll see that in a couple of minutes here. So what happens is the fish will eat the plastic, and then I'll give you one guess to see who will eat the fish. The answer is the humans who fish it, right? So what's going to happen? Well, they take the fish, they cook it, and voila, what do you have? Little fish, looks like he's got shrimp here too, and he's got salad and everything on the fish. That could be a tilapia, very good fish, You get that in Israel a lot. It looks just like that when it's cooked. But who knows? You see all these colored particles? That's plastic. That's going to be picked up by the fish. So what's going to happen? It's going to wind up in the gills, okay, in the liver, in the muscles, the gastrointestinal tract, and the skin. Okay, look what's happening. You're going to cook the fish. Some of the plastic is going to go inside the gills of the fish. Okay, then you cook the fish, and I don't think the cooks are looking for little pieces of plastic, right? They'll just throw the fish in, fry it, and then serve it. Okay, so it's a very good picture on what happens. And then the sun's action is sort of going to do a little bit of decomposition. And like I said, make the nurdles. That's why you see all these little, whoops, hold on. All these little colored parts. What's going on there? I press, never mind. Anyway, you see the colored parts there. Let's go here. Yeah, well, anyway, okay, let me go on to the next one. Now, here we see a lovely picture. You see a lot of plastics, and you see this little fish swimming around, okay? These are actual photos. I doubt that was Photoshop, okay? Now, I want to point out that these are the types of plastics found in the environment, and not only are you getting bottles, but you're getting nylon and other things, other plastics. But one of the things that really bugged me tremendously is rope and nets. Okay, you find a lot of used garbage nets. Fishermen dump their nets in the water, and many of them are plastic. They don't use the regular material now that cloth and things like this for nets. They use nylon, and nylon is impossible to break down. You ever try tearing nylon? Right? It's not going to decompose. It's not going to break, and And this really annoys me. So, but as you're gonna find out at the end of this lecture, we do have some good news about that because there are some people that are really, there's a special website that I'm gonna show you afterwards, how you can help clean up the oceans actually, and we'll get to that later on. Now, here is this little copepod, okay? Notice, what do you think those colors, threads are? Plastic, okay? Now, here's a picture of a copepod swimming. And for those of you who don't know what copepods are, I doubt many of you have ever seen one. There are about 11,500 known species. By the way, the word is spelled C-O-P-E-P-O-D, okay? They're related to insects. They're arthropods, okay? Roughly far away from insects. The most abundant animal on the planet, okay? You have trillions and trillions of these. One of their advantages is that they're part of the food chain, okay? Especially fish and other animals eat the copepods. Now, shrimp and other animals eat it. So look at this. Let's say you eat this copepod. Well, you're not just going to get the copepod. You're not going to separate out the plastic. The shrimp, the fish, whatever eats it is going to pick up the plastic. You see that? And like I say, this is one of the major food items in the world for aquatic animals, okay? You got whales, you got fish, you got shrimp, birds might eat them, things like this. So again, I love copepods because I used to work in Israel on the Sea of Galilee, and that is one of the major organisms that we dealt with there. So I know a lot about their biology and stuff because we had to determine how the quality of the water is being degraded. And of course, you can check the copepods and you have various species. But again, these are the most abundant animal on the earth. I'm going to ask anybody here, anybody, has anyone ever seen one of these under a microscope? No, because some grow about as big as an inch, but the majority are a couple millimeters or less in size, okay? So they're real cool organisms. I love them. All right. Now, here we see something real interesting and sad. Here we see a turtle. Now, can you all make out what's on the left of the turtle? Those are pieces of plastic found in the stomach of the turtle. And remember in the beginning, we mentioned, well, why did we go to plastic? Because we were killing animals, right? The tusks from the elephants and the shells, we made, things out of, okay? And they realized that if they keep using elephant tusks for piano keys and turtle shells to make guitars and other things like that, they're going to go to extinction. So, as they mentioned, the fellow who invented plastic, his name skips me at the moment. And so plastic took the place of the animal. But now, isn't it ironic? We wanted to save the animals, but yet now we're killing them with the substance we made to save them. Kind of ironic, isn't it? You get the idea? Because, okay, we're killing them. How do they kill them? Well, all this plastic's winding up, well, not all of it, but a great percentage of it is winding up in the oceans. It's going to be ingested by the animals, and the animals are going to die. So here we want to save the turtles because we want to save the shells, but yet the turtle is dying because he's eating the plastic that we're trying to save him from. Kind of ironic. Well, that's so much for the human race, you know. Now, those of you who like clams and oysters, as a rule, I myself don't eat them, but you should eat them, no matter where you get them, because here you have a couple issues with these, okay? We got to worry about getting diseases such as hepatitis and things like this, okay? But these days, they figured out a way to prevent you from getting hepatitis and other bacterial diseases, okay? What they do is they take clams, they just don't take them out of the ocean and eat them. They put them in a special purification facility called a depuration plant. Comes from the word purify. So they put the clams in or oysters for 72 hours. And you know how these things live. They have siphons where water goes in and water goes out, right? So it cleans. So in theory of this, they put the clams in fresh water and the clams will pump out the water because it'll clean out their bodies with all the bacteria and stuff. But I don't think when they started that idea, they thought about plastics, you see? So even though you have these clams and oysters in a deporation plant, for 72 hours, the water goes in and out through the siphons. That's how they live. That's how they get their oxygen. You know, they suck in the water and out. And the plastic's going to wind up in their body because it's not really going to be released. Now, we had here in the Great Lakes an infestation of the zebra mussels, okay? You know, the mussels are not only the ones in humans. You know, we all have mussels. In fact, I always ask people, how does the people who live in Florida and the ocean, what do they have in common? The answer is they both have mussels. But anyway, you get the idea. So anyway, so the mussels are actually good in one respect. They purify the water. So when we had the outbreak of the zebra mussels here, by the way, the genus is Drosera. Anyway, I think that's what it is. Anyway, it'll come to me, the genus and species. You have so many, they actually filter out the water of the Great Lakes, so they clean it. All right, see you guys. So they clean the water that way. So when you have millions and trillions of mussels, it cleans the water, but obviously they become a pest. And they clog up pipes and things like this where you get the water from. All right, so anyway. So you might think after these things were usually kept in clean water. See, it says so up there, clean water to get rid of the contaminants. They expel some microplastics while others remain inside. And they reach the market, which means they're going to wind up in the humans who eat the clams and oysters. Okay. So obviously, you have to be careful with that. Now, here is something else with plastics. And this is really quite sad. Here we see a dead bird and he's decomposing. Well, notice, normally his whole body is supposed to decompose. But if he has eaten plastic, the plastic stays in his body. You see that? And that's going to probably last forever. Now, here is the issue with that. You're going to wonder, well, why on earth would animals actually ingest plastic? Obviously, it has no taste. I'm sure many of you have stuck a piece of plastic in your mouth. You know, plastic spoons. You get them when you eat ice cream at these, places where you get the frozen custard. They give you spoons. You stick the spoon in your mouth. Obviously, it has no taste unless you have the custard on it. So why would animals eat something that has no taste? The answer is very simple. Because the plastic that they do eat has taste. Where does the taste come from? Well, the taste comes from the animals that live on the plastic. Sometimes algae grow on the plastic. And then they secrete chemicals, one of which is called dimethyl sulfide, which is actually the nice smell of the ocean. Okay, you ever smell the ocean? It smells nice, assuming you don't have pollution there. It really does have a nice smell. By the way, my degree is in marine science, so I love I do marine biology. So my degree was actually in marine science, and I'm from New York. Even though I lived in Israel, but I'm from New York. Okay. By the way, we spell it W-A-Y. York, Y-O-W-K. The R, we don't pronounce so much, but you get the idea. Anyway, I guess you can tell by my accent. Okay. So anyway, so they produce these substances, and then an animal will think that plastic is actually the algae or the animal. You understand? That's why they eat it. They did studies of these. So the algae are growing on the plastic, and maybe it will emit the odor, and an animal will be swimming. Boy, I'm hungry. Hey, look at this thing. It's really nice and big. It smells like the ocean. Let me go eat it. You see? So he's eating the plastic. You see? So this is what they did. And here's a good picture too of something else. Not only do animals eat the plastic because it smells like plastic, or tastes like, it smells like algae, and it might look like algae because algae grow all over the place, and they'll grow on the plastic because you have a lot of nutrients. They do it by sight. So here we see turtles are known to eat jellyfish. Okay, but if you look closely, the jellyfish, that's a jellyfish, looks like a plastic bag. You see it? And they've actually photographed these with movie cameras. Okay, so they see the movie cameras photographing the plastic. And that's neat, huh? There's a white jellyfish, and a lot of jellyfish are almost transparent, like the world's most deadliest one, the Chironex fleckeri, found in the Indo-Pacific region, which is right above Australia. That is the most dangerous part of the world to go swimming in, or at least it used to be, because of all the poisonous life you have there. You understand? So that's the Indo-Pacific. And there is the Chironex fleckeri, also known as the sea wasp, will kill you in 4 minutes, or even less than that. You need approximately 10 feet of tentacles to touch your body, and then it will release the so-called nematocysts containing the poison. And, you know, unfortunately, it'll stop the heart and you will not survive. Okay. But anyway, jellyfish are immune. I mean, turtles are immune to this for whatever reason. They can eat all these and say, boy, yummy, yummy, good for the tummy. You know, they're having a good time. But as you see here, if you're in the water, you can't really tell the difference between this and that. Wouldn't you say that bag looks somewhat like a jellyfish? Yeah, because they're not going to differentiate. They say, hey, look, there's a jellyfish. Let me go gobble it up, you see? And then he'll choke on it and starve or whatever, you see? So, and these are known facts that they have lots of pictures of turtles eating paper bags. Okay, now, being in the environment, since I deal with pesticides and things like this, we have to worry. There are two terms that you should be familiar with associated with plastics and any chemical, even the ones you get here in the foods you eat. And those are bioaccumulation and biomagnification. Okay, I don't know if have any of you ever heard of these terms? You did? Good. But now you're going to hear more. These are very important. Bioaccumulation is the accumulation over time of a substance, including pesticides, heavy metals, or whatever, and even plastics, because that's what this lecture is about. And if you notice, this is what happens. Bioaccumulation means, okay, let's say you're a fish and you eat an algae. You have a very small, incredibly small amount of the toxin is going to be in the algae. Yet the algae is going to have a very small amount. But just like everything, as I mentioned before, it's going to keep accumulating. Like I said, how do you make $1 million with pennies? You just keep adding them up, right? The same thing here. 1 penny, 2 pennies, 3. It's like the longest journey starts with the first step. So you keep walking and walking. You keep adding pennies. You understand? To increase the mileage, to increase the amount of millions. Get $1 million, and then here the same thing. So you have a small amount of algae, but don't forget, the bigger the fish is, what does that mean? He has lived longer, therefore he's been eating all his life, right? Let's say he lived for 10 years. Well, he's eating 10 years worth of algae. You understand? Each of those algae has a small amount, like the penny, but it keeps adding up. You get the idea in his body. So if you count the number of dots here, notice how they're the algae with the plants. By the way, I do a lot of work with algae. And as you see, here's a copepod. By the way, those are copepods that are going to eat the algae. Zooplankton, little animals like copepod, they eat the algae, which contains small amounts of chemicals. And then fish will eat the copepods. And notice, you see these dots, how many more dots per area you have? And you keep adding it up. It's going to keep adding and adding all the way up to the kilowatt, or whatever. You understand? So this is a typical food chain. And by the way, typical food chains begin with plant-like substances. In the ocean, it's algae, which are microscopic plants. And out here, we see the trees, the grass, whatever. That's the plants. And most people, every animal you eat, eats plants, either one way or another, like a cow. Cows start with the hay, that's a plant, and then you eat the cow. You understand? Okay. By the way, there's a story. Someone asked me, said, David, why do cows have bells? I said, I didn't know. He told me, because their horns don't work. Just thought I'd mention that one way or another. I'll get the idea. All right. Now, then we go on to biomagnification. Now, what do we mean by that? Well, notice that when you eat a toxin, it's going to accumulate up the food chain. So you have your water, let's say a little bit of the chemicals in the water, then the algae will uptake it, will take it up through its membranes, and then the insects or animals will eat the algae, and then another you'll have a worm or a larvae of some kind will eat the insect, and then the insects will eat the larvae, and then the fish will eat the insects, and then another fish will eat the fish that just ate the larvae that ate the insect which ate the larvae, which ate the algae, which were in the water. You see how it goes up the food chain until finally you guys, which are called humans. You see that? So that's how this stuff goes up the food chain. Okay. Very important concept. And that's called biomagnification. And here I have some chemicals that I want to show you about some of the illnesses that humans get. Okay, here's one called polychlorinated biphenyls. This was a famous one. So, it's called PCBs. That's the chemical structure. I figure from talking about certain chemicals, you might as well see what it looks like chemically. And then we have the bisphenol A, and that was a big issue, especially with bottles. And they were worried about that, especially baby bottles, because babies that would drink milk or whatever's in the bottle, juice, water, whatever, they can pick up this bisphenol A, and that's no good because it might lead to cancer, you see. So everything we do, we try to make life easier, but then again, we don't realize it's toxic. Now, these are the major issues when we talk about routes of exposure, okay? And we have the main routes, of course, are ingestion, which means eating it. Inhalation, you're breathing it. You live in a polluted, air polluted society. And then dermal contact, you get it from skin, right? Now, these are the types of illnesses you get. Oxidative stress, and by the way, many of you have not heard of that, so I'm going to play a quick 1-minute movie on it right after this, so you know how bad it is. You have oxidative stress, which means the cytotoxicity. It's poisonous to the cells, and I'll explain what that means. Then you have altering metabolism. Okay, obviously your metabolism, that's how your body functions, is going to be messed up. You ruin your immune disease, right? I mean, your immunity. That's what the white blood cells do. They're mainly involved with your immune system. Translocation means moving from one organ to another inside the body. And then neurotoxicity, this is the toxicity of the organisms. It affects the nerves. And by the way, speaking of nerves, I should point out, I've gotten on many people's, but that's another story. And then we have reproductive toxicity, where you see it can affect future babies or something, of course. It might give them birth defects or something like this. And of course, cancer risk, which is carcinogenicity. Okay, now I'm going to play for you a quick movie on oxidative stress, because I feel you should know what happens. Okay, and essentially what that does is it's an imbalance, okay, between free radicals. And a free radical means it has a charge. It normally has to hook onto something, but a free radical has an electron, and that electron is going to try to grab onto something. Well, the electron is part of a chemical, but I don't want to go into the details with that, because that we do in chemistry. Let me play this for you. And there might be a commercial here. I hope not. There it is. Let's give it time. It's only a minute if we can get it. Well, let's start it. There it is.
As a result of oxidative stress accumulating, the cells start to lose function. In this example, mitochondria, or the engine of the cell, can't operate as efficiently, and the cell membrane starts to lose integrity and fall apart. As a result of this cellular damage, entire systems can start to fade. We'll give you some specific examples later in this course, but the concept to understand for now is that oxidative imbalance can lead to damage to cellular components. Damage to cellular components can result in cell death. Cell death can threaten the integrity of major systems in animals. And when major systems are compromised, efficiency suffers. In the end, our cow that was a healthy peak producer is no longer able to perform as efficiently. And that costs our customers money.
Yeah, so there are many of these videos on oxidative stress, but I just wanted to show you a short one just to give you an idea. what it's about, okay? And then here we see more disorders, metabolic disorders, disturbances. This is a case too, where young girls can reach puberty by the age of 8, okay? Because you have estrogen-like compounds in your body, and that's gonna cause the onset of puberty at a very early age. Obviously, that's no good. So you get the ideas. I don't have to go over all these again, but that's the main thing that I want to show you. Other effects, hormone problems, lower sperm counts, negative effects on immunity, and some of these chemicals stick to pollutants such as the PCBs, polychlorinated biphenyls, and they're obviously dangerous for the body. Okay, now, how do we remove plastics? This is the important thing, okay? How do you prevent it? Well, you can get certain filters, carbon block filters, which are very good. I myself have one at home. That's where the water goes through, and it's activated carbon. It's a big block, okay? And the carbon traps the chemicals, okay? Both physical and chemical wise, okay? And then you can have reverse osmosis to filter out up to, now get a load of this, 0.001 micron. Micron was the old name for the word micrometer, which means it's 1/1,000,000th of a meter. So you have a meter about this big, and then you divide it up into 1,000,000 parts, equal parts. That was the old micron, okay? So a micron now is, they use the term micrometer. It's just convention now. They changed the word, okay? So that's 1/1000th of a micrometer. We'll remove that, the reverse osmosis. And by the way, reverse osmosis is the way they get rid of salt in, it's a desalinization plant, the kind they have in Saudi Arabia, you know, to purify the seawater so you can drink it. Obviously, Saudi Arabia is a desert country, and they don't have much water, so they have to take the water from the ocean, and they have to take away the salt. So they use desalinization plants, okay? And then you have the distillation filters that deliver water, and does also, and it filters 100% of the known plastics. But probably, as you can imagine, using these other techniques get quite expensive, okay? Now, here is something I wanted to show you. What do you see there? Well, on the left, you see a park bench, right? What's that made out of? Anybody want to tell me what that bench is made out of? It's wood, okay? Anybody want to tell me what this is made out of? This bench here is in the Metro train station up at Edgebrook. Number 2, plastic. And what bottles are number 2? The plastic milk containers and the containers which hold soaps like Tide, okay, right? So literally, you can wash your, you know, when you wash your clothes with Tide, if you recycle the bottles, you're turning the tide. The plastic, that was a cool one. I just thought of it now, figure why not? But anyway, see, and these things last longer. These things will hardly ever break down. You see it? Look, this wood's decomposing. That's I forget what that is. I think that's at Oakton too. I believe that's in front of the building. I don't know. I just happened to pass it. Fortunately, I had my cell phone. I got to take a picture of it and use it, because you should always have a camera with you. Anyway, see the idea? It's beginning. It's not really in great shape. It's peeling. I don't know if there was ever paint there, but it's peeling away. This will never peel. See it? And actually, what you can do, this is also called Durawood, at least it used to be. And they take the number 2 milk containers and Tide containers and other number 2 plastic, which, by the way, the name is high density polyethylene. So it's HDPE. That's the abbreviation, all capitals, HDPE. And they make benches out of it. Also, HDPE is what they use in liners in hazardous waste landfills, okay? No, I don't want to go into a landfill. We discussed this in my environmental class, but they make landfills, and you know, you have to make sure that nothing's going to go into deep into the water level, that's into the water table. So they have to layer it with the high density polyethylene. It's like a blanket you put under there to protect the ground from getting contaminated, okay? And now I want to show you one thing. You know, as I'm doing these articles, every day I find something and I say, man, I'm finished with the article, and then something else comes up with the newspapers. And I want to point out too, that at the present time, I'm doing the second edition of my second book called Prognosis Disaster. I know, very optimistic title there, but, so I sent everything in to the publisher, and just when I'm sending it in, there is something else pops up in the newspaper and the news that I should have put in the book. But I can't keep doing it because every day, so I'll never get it done this way. So I just send in whatever I got and mention it. But every day there's something. Now, you see all these articles there? These are all articles, but wait, every single one of these articles came from this article. And then if you go to those articles, it's either red or underlined. Let me show you this one. See, this one has the title of 600 million metric tons of plastic may fill the oceans by 2036. Now, this comes from a Truth Out, which is an online newspaper, which I read all the time. I get it sent to me by email. You know about it. It's a very good newspaper. And by the way, unfortunately, one of the creators named Williams River Pitt, know him? He just died. He was one of, he was a brilliant writer for this. He was the one that wrote a lot of articles. I think he was 56. He just passed away, and that's causing grief to everybody because people, I don't know, you probably never heard of them, but those associated with the news. And there's also a famous environmental journalist called Dar Jamel. Anyone ever hear of him? He's well, he writes for Truth Out, and he wrote a article about Williams River's pit. Anyway, so let me just show you this. And this article, all those articles I got from were taken from here, the ones you see there. And over here, the way you can get these articles, if you see here, you see everything's black except the word swimming. And so what you do is you put the mouse over swimming, you click on it, and then you will get another article. You see it? That's where they get a lot of these from. And from this article, you can get more articles, and the next article more. You can get 1,000 articles just from that one. You understand? If you keep doing this. So here's the another article. See, it's pretty cool the way they do this. See all the plastics coming down and stuff. So they're quite imaginative when you click on. This is from another article. Isn't that something that you get from that newspaper? So if anyone's interested in this, if you can get the zoom of this and then take a picture of the title and look and just put in the title and put it up there, you should get the article without much effort. Here's the newspaper again. So this one really caught my eye, and I just saw this 2 days ago before as I was preparing for the lecture, and I said, man, I got to show that. See, so this tells you plastic everywhere. That's one heading. Stepping stone to change, recycling, and unfortunately, we like recycling, but most people don't do it. Seeds of change. Recycling is still important, but the resolution of the plastic requires swift and practical action steps that I doubt will be taken because our politicians on both sides of the aisle don't have much guts. I'll tell you that. And that's why we, the humans who live here, have to do something. So you can gather everything, what you see there, all these other topics. And again, this is just a microcosm of what's out there. I mean, we are being bombarded with research and newspaper articles. Now, this is the organism, the organization that I told you before. If you want to learn about cleaning up the oceans, this one is 4ocean.com. Okay, and I think what I'll do is I'll just try to show it to you real quick. It's real easy to get to, 4ocean.com. And let's see here. And that's the number 4. Let's see. It's really cool. I don't know why they're not org, but there it is. See it? Deep sea collection there. Okay. So anyway, this well, we don't want to win anything here. Okay, it's a pretty cool website. Okay. See, and they show you, this shows you global impact. This is pounds of trash have been pulled from the world's ocean. Look at that, 25 million pounds. Isn't that something? since January 2017. And that includes everything, paper, plastic, whatever you got there, glass, who knows, see? And then they make things out of it, okay, like bracelets and a whole bunch of stuff, see? And then if you want, you can join or you can find out where they are and then you can help them. I doubt there's much you can do with the plastic problem here in Illinois since we're in between the two major oceans, right? But anyway, you get the idea. Okay. Now, one more thing. I'm almost finished, folks, so don't worry. You can go back to your daily routine here. Let me see what I got. Okay, now, whoops, let me finish. Almost finished here. Let me go down here. Okay, now I wanted to show you too, one other thing, or two other things, actually. This, if you want to watch, I gave a lecture in 2017 about the garbage patch in the Pacific. And to watch it, you can go to that website up there or directly, not with the URL, okay, I mean with the QR code, but in fact, I'll show you how to get it from my webpage, which is up there. My webpage is davids-earth.org. And if you click here, if you click on the QR code, that will take you directly to my webpage. You can even do that here with your camera. And that will take you to my webpage, okay, the QR code. And if you want to see my plastic lecture, you directly just click on this one there. But I'll show you my webpage. So it's real easy to get to. And I got 100 sites you can go on there for the environment here. It's real simple. It's a real cool webpage. Show it to you. And I got a lot of stuff on there. It's just Davids, DAVIDS-earth.org. Okay, and that'll take you. See it? And there's the web page. And you can get, this is a whole list of web pages associated with the environment, okay? And one other you'd be interested in, I put there the web page of all my lectures, which are on YouTube. I have a YouTube channel, and it's real easy to get to. Well, by the way, this is a link to a 140-page article that my friend Peter Winkler and Jacob Paz and Jacob Nieve and myself wrote. We went to a meeting in May in Grand Rapids, Michigan, about it was one of these professional meetings called the Joint Aquatic Science Meeting, and we had 9 organizations, those dealing with aquatic environments and animals and you know, rivers and things like this. And I belong to the Algae Society called the American Phycological Society. Sounds like psychology, but it's phycology. Phycology deals with algae. And so we have a 140-page document here because we're writing another book, Peter and I, about algae. In fact, there's the name, approximate name of the book. And we wanted to get some information, and perhaps people there could help us, you know, write it or get some information. But over here, if you want to go to my website too, from here, you see at the bottom of this is the Borneo rainforest. You click on here where it says David Arrietty's lectures on YouTube, and then you click on that, and then you will get this page. There's my web page. There's me examining the earth. This is the cover of my first book called The Earth is My Patient. And then if you want to see all the lectures, you click on videos, and then I got about 25 of them here will show up. I've done more than that, but we're trying to put them on now. See them? And there's one on the garbage patch, which is this one there. That's the one that I have listed right there, which deals with the plastics in the ocean in the Pacific. Okay, so if anybody needs that, that's my webpage right there. I've done a lot of stuff. All this is scientific stuff. I actually have one too that doesn't deal with science. It has to do with my father. And if you want, you can learn about him too. But he was, I just put that on because he was a psychiatrist and he did a lot of work with schizophrenia. So I spoke about him. But other than that, all the others deal with science and biology, environmental science and stuff like this. So I think, other than that, I might be finished. So are there any questions, comments, anything? Yes? Yes, I think they're doing that now, as a matter of fact. They're doing that for oil. Yes, the question was her name, Laura, was it? Laura, yeah, how's that for memory? I mean, my mind is still there, right? Yeah, Laura asked, are we genetically engineering bacteria to gobble up plastic? And the answer is they found enzymes which will do it. And we do use bacteria to gobble up hazardous waste and oil now. Okay, so they actually do that. It's a very good question. I'm glad you asked that. And yes, they're working on that now. So when we have these horrific oil spills in the ocean, they put the bacteria on it. And it's not easy. You have to acclimate the bacteria first, you know. You have to get them used to oil, and then you stick them in the oil patch and they gobble it up. And they actually did that in Thailand many years ago with sewage too. And then you can eat the actual, they were growing stuff, I don't know. But anyway, it worked. I'm not saying you should eat the sewage, but you can grow plants on it and eat the plants. I think they were using seaweeds and stuff, something like that, and it seems to work. If I remember correctly, this was over 50 years ago, so maybe things have changed, but they're absolutely bioengineering bacteria. It's really cool. By the way, bacteria, I discussed this in my class. Do you know another use for bacteria? They make insulin, human insulin. Did you know that? Yeah, they're doing that. That's where you think a lot of the insulin comes from. It used to come from cadavers, but you know, human cadavers and cows. They used to take it from the cow pancreas, but now they manufacture it in bacteria. So here you have obviously bacteria, not human, but you're producing human insulin in bacteria. You know what that's called? They call it humulin, Humulin. That's just one example. So we are really making, I'll just play it here just to show you that, not show you it, that we're making great strides now in genetic engineering, thanks to Watson and Crick. See the work, they see humulin, and that's the best thing. That is the, see it right there in the bottles? That's insulin made from bacteria using the human genes. It's really incredible how they do all this. And by the way, they just discovered enzymes, special enzymes to break down plastic in other organisms. So they're probably doing genetic engineering with the bacteria, and maybe they can make the enzymes in the bacteria to do that, because we do make enzymes. Did you ever hear of cystic fibrosis? That's a disease. Anybody ever hear of that? That's a disease where you have a lung problem and you can't break down the mucus in your lungs. Everybody has mucus, but now you're all here breathing fine. Why? Because you have the enzyme to break down the mucus. You don't even feel it. So what they did with the cystic fibrosis patients who have a problem making the enzyme to break down the mucus, they grow it in a cell culture, the cells, and then they have a virus where they inject the proper genes into the cells, and then the patients have an inhaler with their cells made with the genetically engineered enzyme, DNA, to make the enzyme. They inhale it, you know, just like people with asthma. You inhale, and they hope the cells from the inhaler will stick to the lungs. They'll grow and produce the enzyme to break down the mucus. And they've had success with that. So it sounds like science fiction, all this, but it's coming to fruit. Just like, remember, going to the moon was science fiction, right? But now we go to the moon like nothing. At least we stopped. We're planning to go again. There are a lot of people I'd like to send there on a one-way ticket, but that's another story. All right. Anything else, folks? That was a good question. Yes, Olabisi, yes.
We were consumed on microplastics or polluted into the ocean, and then we assumed those fish.
Wait, I missed the last part. Wait, are you saying that the fish will eat the microplastics, right? And then another fish will eat the
Or
fish?
no, just like fish or other aquatic life that eat those microplastics. Since we eat those. fish.
Oh, will humans get it too? That-
Yeah, I'm just wondering, do you have an estimate of how much lives in our body?
Well, the best estimate I have, and I myself go through the research based on what it says, If you're unlucky enough to week, you get about a credit card worth of plastic. Week, but I can't that much, yeah.
That's too bad, but the reason so we use that plastic, we exhale plastic.
I don't know about exhaling, because you want my whole.
To evaporate plastic. Because obviously, like animals, when they're starting to death, we don't start to death because our stomachs are full of plastic. So, to somehow evacuate it.
Oh, that's a good question. I would assume we do, but some might stay in. Depends where it gets stuck in the body. Right? You make a good question. Obviously, everybody moving around, you're not eating like a whale that has 200 pounds in the stomach. Because see, they just gobble up, you know how whales eat, they just grab whatever's available, but there's no whale supermarket.
Another important thing is that when animals eat plastic, that's a long in their diversity, right? Usually when you do that, 33 organs, when you burn those plastic is.
The point is, you're right, you're still getting it, and you eat shrimp and stuff, and all these other fish, some people eat. Don't some people eat the guts of clams and stuff? Hey, that, right, here it is, wait, sorry to say that. If you eat oysters, you're eating the guts. If you eat the clam, you're eating the muscle. You're not eating the guts. Sorry, to be so gross about it.
But yeah, the main concern about microplastics in human biology is that really any pieces that are actually microscopic, those can actually become sleep and there's. They don't really like to want that.
I've seen, I did not, like, we don't know the lady knows too much about it, but she saw like the correlation with, like, low fertility
Yeah,
in men and women, and like, it can actually, like, the amount of microplastics phthalates and then what?
yeah, who did that research?
I can look it up.
Yeah, and actually, it makes sense what you said, and as I mentioned before, the lower sperm counts. And then this is gonna affect the reproductive behavior because it's gonna mess up with the hormone. Right,
It's called
wait, what's that?
And the other thing one should be really important.
Right, premature puberty. Is that what you said? Yeah. And, you forget that you're not really gobbling up pounds of plastic, little micro, it's not gonna clog up your digestive system with the fish, unfortunately. They have no choice, they just grab whatever they can get, and unfortunately, it's terrible now, we smoke the whole environment, the fish, the water, the air, right? The land, you gotta feel sorry for the worms. And you know what's wrong about that? Mud that kind of annoyed me. I was, many years ago, they were cleaning using soap and water, in a bucket. And they poured the soapy water, this was in the summer, on the grass. And so all the hundreds of worms were coming out. So they were going to drown. You see, they breathe through their skin. And the soap caused them a problem. I felt sorry for them. They're just stuck there with human activities. That tells you how many worms, again, millions of worms, spread out. Yeah, they do want to. All right, thanks for both of you. What's your name?
Nolan.
What is it?
Nolan.
Oh, Nolan. And there's Laura. Have you checked it? Did you find it yet?
I also have two questions.
Yeah, go ahead.
I haven't seen any copepods before, but I have seen ostracods.
Yeah, I forgot. Those are crustaceans too. Those are the ones with the little like shells.
Is the you said it was a sea wasp? Was that another name for the Portuguese man o' war?
No, the Portuguese man of war is not. That's the Portuguese man of war is the name for the genus Physalia physalia. The sea wasp, I'll show you. It's Chironex fleckeri. That's by the way, that's a siphonophore.
Yeah, that's why I was asking.
Yeah, the Portuguese man of war is the only name that I know of. It's the generic name. Physalia physalia is the genus species. Yeah, that's because the pneumatophore, which is the name of the float, so it's blue and it floats on the water. And you do have some of these. There's another one called by the wind sailor. You ever see that? That's another jellyfish that floats on top because the wind will move it along.
It is really interesting how those are like.
Right, but the Portuguese man of war is a colony. You have a bunch of zooids. So they have the feeding one, the reproductive one, and the moving one. Oh, well, that's what it is. Yeah,
The lady was Shannon Swan.
SWAN.
Swan, yeah.
What did she do?
She wrote a book called Countdown: How Our Modern World is Threatening Sperm Counts, Altering Male and Female Reproductive Development.
Right, well, that makes sense. You know, remember, and by the way, they figure the world's sperm count in humans have dropped by half because of all these chemicals, you know. Hey, I'm gonna tell you, so I gave a lecture too, you might find it on the ones that I gave. How? Here's the issue. We know we're screwing up the environment. Guess what? We're doing it anyway, right? Look at the oil companies. They're still pumping away, right? When they know their product is killing the planet. And by the way, there's a fellow, I mentioned this in one of my lectures, Wallace Broker. He worked for Exxon in the 70s, and he told them, the bosses, like, who was the other guy? Not Tillerson, the guy before him, Rex, what was his name? No, not Rex. Yeah. No, not Rex. The first guy, I forgot. He's the guy before Rex Tillerson. I forgot his name. And, you know, he knew his product was screwing up the planet, and they told him, but he didn't care. He says, my stockholders, I care more about them than the environment. You understand? And that's what happened. Yeah.
I just wanted to add that Oakton, although, you know, we have such a situation with plastic, we just trying to reduce our plastic consumption. So we recently started collecting plastic bags for recycling, so students can bring their grocery bag here on campus, you can drop it off at the pizza in the lobby, or in Woodbury by the Performing Arts Center, and that plastic gets melted down and turned into alcohol bags. So that does not end up in the landfill or our ocean experience and state production. Alternatively, just to respect the time, on your way out, please grab a bamboo utensil set. It will help reduce any kind of like single-use plastics into the community. Yeah, they just got.
I gotta show what you're gonna get. By the way, the guy's name was Lee Raymond. He's the one on the right. These guys are millionaires. By the way, this comes in after that. You gotta say here, and they got something real interesting. Let's start with the best one. You know what this is? It's metal. What do you use it for? The straw. So you keep it and wash it. You got it? Right? Made out of metal. Then here you have a whole set of silverware. But it's not silver. Wood. Yeah, not bad. You got a knife. What kind of wood? Like that, you know?
I think it's bamboo.
Bamboo. By the way, it's Halloween now. You know what? Why bamboo is the plant for Halloween? Because it has the word boo in.
And
Hey,
for,
thank you. Nice to meet you. All right, take care. Yeah.
and for Earth Week, we're hoping to do like a plastic litter collection and back away from the kind of stuff. So we can buy it for them.
Yeah, Earth Week comes in, it's in April. And, anyway, are there any other questions, anything? By the way, wait, something else. Oh, hey, clean the straw. Oh, spaghetti and hot dog, look at that. You got a straw. Nice.
If you need extra credit for attending the event, just let me know if I could send out some cheaper.
Yeah, go grab one there. Guys, you deserve it for attending the lecture. Well, thank you for coming. And I have my webpage, and if you need to get a hold of me, I'm here at Oakland. Just say David Arietti. Ask anybody, because the secretaries, I've given them permission to give you my name, address, everything. Got it? I give everybody my cell phone, my home phone, my work phone, my email. Here, the Oakland number, in case you have to get it. I even tell my other colleagues to get a hold of me. Call me here first. I live nearby. I live 5 minutes from the Skokie campus. So you can always get a hold of me if you need me. And I'll be glad to answer all your questions. Thank you for this. Are you studying environmental science? You want to?
It's usually interesting.
Oh, good. I'm glad. Yeah, look up ostracods. They're pretty cool. Hey, fish love them. To eat them.
It's funny that people would.
Yeah, they do. Once I saw in nature in the pond around here, big one, about half a centimeter. So, yeah, just since you mentioned ostracods, I'll show you what they look like. since I doubt, see, I'm big on aquatic life and, ostracods, they're pretty cool. We got, there we go. Did I spell that right? There we go. Here we go, ostracods. And what makes it interesting is that the female has their eggs. You can actually see, let's look at females too, ostracod females. The eggs are in the body there. You'll see it's real interesting. Let's see, images. Ostracod, ostracod females. Hold on. I'll just show you since. Well, I don't know. Let's go up to images. Yeah, this one, I don't know. Well, you can actually see the round eggs in their bodies. Let's see, I don't know. Well, anyway, look at that. Just when I want it, I can't see it. Oh, here they are. I think those are them right there. See the eggs up there? Isn't that cool? So these, yeah, these are the eggs right there. See them? Of ostracods. That's what they look like. Fish love them. They have sort of a shell on them. So that's what it's like. Yeah.
Kind of weird because they're like a bivalve of their crustaceans.
Exactly. Yeah, the bivalves are the oysters and clams. Yeah, right. The crustacean related to insects. Well, it's a class. Insects, crabs, spiders, these are all arthropods.
Well, insects are technically classified as crustaceans, also, like insects evolved from crustaceans.
So they did what they go into the class insecta. I don't know. That's what that could be. You know, the crustaceans are crabs and stuff, but the insects are class insecta or class hexapod.
Which evolved from crustaceans.
Yeah, they probably did.
They're closest to crustacean relatives are brine shrimp.
Oh, the brine shrimp, yeah, salina. What is it? Artemia salina. The brine shrimp. They use it as a food source.
Oh, yeah, I know, especially for fish.
Yeah, fish love them. Okay, anyway, so you learned a lot today. Anything else, comments, complaints, anything? Well, thank you all for coming. You can always contact me. Call me anytime. I am very open. Anyone wants to talk to me all the time. I'm free. All right, thank you. Thank you for the applause. Hey, what's your name? Yeah. Oh, Earthside, right. I never met you because you weren't at the other camp. Oh, yeah, I'm actually. Full time? Good. Very busy. Yeah, I like doing it. Try to take. We could actually remember very simple, use the money instead of building chip. Helping countries need the help, therefore, they don't want to be. Yeah, so it was the way they put it. You know, to say this down over, they just text. Go to the whole world. However, it would be great if they can actually put some out here and bottle it up. So maybe we could roll on it. And then the other chemical, you know what they did before. Break it up. Make it, you know, they used to do that with Thailand. Instead they used to do
Yeah, the residue, and it's not, they did research on it.
Yeah. And it also be color
Yeah.
or other factors, but
So I keep that over the days, one is not. And that's it, I got the research. Fine. We don't know everything out there. Right. And that's what, how we did all the research. We gotta stop. All the time. You know what? They got that large, they got one night was open.
right.
Yeah. And then they want more, and with China, I don't want to buy a lot of it. They're doing fine right now, right? So they could go and get, over the contract.
Yeah.
There's no reason. Let them do it, what the hell? You know what that means, they really go all out on both sides, millions are gonna get killed. Yes.
Yeah.
Exactly. Like, what? What do you do?
I live out.
Oh, I know, I used to live there, I'm happy to leave.
Maybe I live on.
Yeah,
Power, premium power.
yeah, I used to belong to, I was in the synagogue, for the main dining, my flat, there was someone else with water. No, they had to sell the building in 2003.
Okay.
I remember that, they before.
Wow.
Now, see what happened, we were bought out. Charity, where we joined, charity things. Then they, now, I'm in. Over that. From where I live, I think they're not really.
But we're building stuff. Yeah, we're building all the time.
It was, when they did, I don't know what the other thing.
I totally understand. I don't understand. Yeah, I don't really understand this in ways. It's like, maybe the outside is basically exposed. Next door, I guess. It's kind of like kids.
Yeah, that's what they want, they make it cool, I think we get.
So that property that's on the corner that they made school and also school, that part of that.
I don't know. Yeah, I don't know what happened. I was just upset.
Well, yeah, no, I understand.
I knew this problem.
Oh, okay.
Yeah.
Where did you go to?
I went to Long Island.
Yeah.
I went to Berks. Elementary was ordered. We have one to five that I went to. What the point is, and that is very clear on, it's like it's good things that make it right. Going to school, and I went to high school, that we were 89 students that were to the private school. Then I went to the University of Memphis.
University. That's big.
And then I went up to Midway to the University of graduate school, Long Island University. Yeah, the one. Hempstead, it was the branch from the one in, Hempstead, well, actually, Sanctuary, he got his Polish in the West. Uses the Marine Cider. There's Wayne, he covered one of those schools. Take,
Yeah, I teach,
you don't work out.
yeah.
I don't think I just. Oh, we'll show you. Never mind, I do.
Yeah, you heard it.
Perfect. You're right, you're right. Sign in. I don't know. Let's look with, trying to get the whole insect, I mean,
I get next.
Yeah, I do too. Right, you have to take it in by force.
Yeah. and he's gonna just go into the video.
No, free, you can discount it. I wanted you all to watch the special.
Yeah.
And it'll be online. Then my two that get off, like, what they. what's the- I like, I want everybody to see what's going on. Oh, yeah, so I. Yeah, what I do is, I'll be my. I have the same, the life of the same soul. I have a camera. And that's the same, we have this standing.
It's still in here.
And it's the one with the red back. Go to the.
I haven't been in the bio, but
Fortunately, or the student.
yeah, right.
I was hoping that we had these items, something very good. And then it's the last man. But these are good, you know, things coming on there.
Oh, yeah, yeah, right.
We had two guys out there, it was the rough, right?
Okay.
That's not the good one.
Oh, the previous. Okay. Well, we got some.
If you're interested, you know, the whole camera setup is on the football.
Oh, okay.
Not too bad. Maybe it's more now, but I got a deal.
Interesting.
Thank you.
Yeah, and I'll check maybe for insurance and behind
Yeah, they get them both. They're involved, and I hope the other one, is a third, a second edition. A lot of people know that. It's in color now. They did a good job. I changed book on it.
Who's it? Oh,
It's called, I don't think you ever heard of it, American Reputation Press.
okay.
Wait, let me give you that name of the press. I never heard of it. All of a sudden, I never the language, they checked me out. And, you know, looking at the other one, the author. And they were terrible. If you believe, I'll tell you this. They sent me a broiler, $18.
No,
And a pound.
no.
So you figure, so I called them up, I said, what's going on there? You know what they told me? Listen, I believe what they told me, I'm the queen of England. They told me that they just put the wrong account. Yeah. So you're, don't put the account in the bottom account, receivable, accounts payable, they gotta know what they're doing. And of course, one of the guys that we do is the company.
Okay.
They can say anything they want. Well, they, oh, it's author. You know, they have a person. Yeah, here it is. Author reputation. I looked at something with the book.
Yeah.
Another thing. They wouldn't even do two indices. They wanted a regular index and one for the organism.
Okay.
They wouldn't do that for the organism. So they have to put on under, you know, regular index, then organism. Put on that. Now that kind of thing they off. This company does it very well. And it's a lot cheaper. So let's see how it comes out. That's what I said. They think pretty good. They're dead for 9 o'clock at night.
Okay.
Yeah, I like it. They're really cool. All right, thank you.
Thanks a lot.
But your office is in here.
It's in the Lee building,
Yeah, oh, good.
138.
Yeah.
5 line here.
Whatever you get, y'all go there.
This is on the first floor.
I was supposed to teach there this semester. I think next semester. And take care. Nice to meet you. Hey, you made my day, man. Thanks. Hey, did you get some of the silverware?
Students have that. I didn't get that. Are you sure?
Yeah, show your stuff. Tell 'em.
Yeah.
Yeah.
You have your book that was written in this language.
Yeah, they're in both campuses.
Oh, really? What are you calling them? Yeah.
I think it's been a while.
Thank you. Hey, I don't believe. Yeah, we appreciate it. Thank you for everything.
I know this. Yes, very. The current about microplastics and how we can make our clothing.
I feel good about polyester, I have that 100% cotton.
Yeah,
Right, I mean, and they have cotton, but it's polyester.
yeah.
Believe it or not, one of my classes, I had one of my students. Polyester.
Oh, yeah.
All right, I'll see you.
Yeah.
Thanks.
Yeah. I gotta shut this off.
So,